They ask it's a question here basically about proportion. So it's a big part of probability in statistics. We kind of read through the problem. It's a short problem or it's a very, very long problem, but there's always a subject matter they're talking about. But kind of independent of the problem, there's a lot of definitions and some basic math. So we're just going through a lot of the definitions here. But we have it right here. So p hat is sample proportion. Yeah, which is a statistic, not a parameter. But p hat is x over n. It's a number out of n. Yeah. And then we have p hat plus q hat equals 1. With population, we have p plus q equals 1. It's just there's an outcome. We get the outcome or we don't. P hat is the probability we get the outcome. Q hat is the probability we don't. Any probability distribution should add to be 1. So obviously, if p hat is, say, 12%, 0.12, Q hat, the probability we don't get that is 1 minus 0.12, 0.9, 0.88. So you always have that. But p hat is typically most important. Q hat is just always going to be the complement, the other one, 1 minus p hat. But it's the other sample proportion. Anyway, so n is sample size. We know that. E, when we start doing more in-depth confidence intervals, is something called the margin of error. It's going to have a kind of a fancy equation. We don't have to do it now. Later, when we find margin of error E, it's going to be p hat, q hat, which is 1 minus p hat. Sometimes you see that over n, the square root of all that with the z on the outside. Whenever we have a square root, not that it's a big deal, but things like that tend to mess everybody up. And then they just have p at the bottom. That's population proportion is all that is. So slowly but surely, we are doing confidence intervals. Now we finally start, this is going to start the confidence interval series. Yeah, a huge part of statistics is confidence intervals and hypothesis tests. Hypothesis tests are definitely more difficult, but there's a lot of steps with both confidence intervals and hypothesis tests, and they are related. But now we're doing confidence intervals. So all confidence intervals for elementary stats, we don't really have to understand the meaning of the distribution that well. It's different for a hypothesis test, but all confidence intervals are what are called two-tailed. So we have this thing called alpha divided by 2. So alpha is always 1 minus the confidence is 0.95. Yeah, the alpha is always 1 minus the confidence. Yeah. And everything has to be in decimal, never in percentage, but that's fine. So the answer to the little question there is that. But in reality, because it's two-tailed, for confidence intervals, we always want alpha divided by 2, which is 0.25. But here they just want alpha, so just 0.05. Okay, so this kind of carries on here. Now they want the z alpha over 2, which is exactly what I'm doing. So there's two typical things for z. First of all, I'm talking a little bit out of order, but when it comes to z, you can refer to a chart if we really hate the TI-84. And if you do the calculator a lot, I start to hate looking at charts. Or for the z, you can just do inverse norm, which is a lot better on a TI-84. But there's kind of two classes will have us do it differently. For z values, we can refer to a chart, or for z values, we can just do inverse norm. But there's more than one source for z values, so basically it's calculator or chart. But we don't really have to read it as usual. That's 82% confidence. So it's always the same for a z. We have to get alpha over 2. Even if we don't quite know what it means, the procedure is always the same. It's always 1 minus the answer divided by 2. So the notation is confidence is 0.82. The alpha is always going to be 1 minus the confidence. Yeah. And then we can do that, but the alpha over 2 is going to be divide both sides by 2. alpha divided by 2 is exactly that, 1 minus the confidence divided by 2. A lot of people still do very poorly in algebra, which is fine. Some of them do good in stats, but they just know that you do 1 minus the answer divided by 2 is all they really know. And then we're not done yet. Yeah, so that's the alpha divided by 2. So what is the z? That's the alpha divided by 2 right there. Alpha over 2 is going to be, in fact, it's not approximately, it's exactly 0.065. So z alpha over 2, and we're going to ignore negative. There's so many little things to say, but people memorize and they don't know, and it really doesn't matter. All inverse norm are left-tailed. Yeah, this is a 0. These are positive numbers, and these are negative numbers. Yeah, all inverse norm does an area to the left. That area right there is 0.065. So if we inverse norm, we're going to get a negative z value. We want the positive one, but it's symmetric, so you just make it positive. So z, and you always report a positive number, is going to be inverse norm. It's second vars. I forgot about that. We're very thorough, but the further we go into the class, I don't like to say all of it. Second vars, inverse norm. With the z, you don't usually have to put mean and standard deviation. It is alpha over 2. It is a just means any generic area, comma mean, comma sigma. But if it's 0 and 1, which it is for all z, then you don't actually have to do it. So technically this will amount to a negative number, but we just make it positive. So it's literally just the alpha over 2. So we plug into the inverse norm, 0.065. And then the z, alpha over 2, is approximately what? Usually 2 decimal places, they agree. So 1.51. Yeah, it's kind of like, what the heck, we do all of that and we get the wrong answer. That's no good, huh? That's okay. So talking through this, we just have a calculational error. We do one little mistake in the beginning, and of course the whole thing is wrong. But now that we know that, let's do this, because that's obviously 0.18. Yeah. The alpha equals 1 minus the confidence. Alpha equals 1 minus 0.82. Yeah. So alpha equals, that's 0.20, I get 0.18. So alpha over 2 equals 0.09. I don't know what I did the first time. I did like an 87 or something. But it is just inverse norm, 0.09, comma 0, comma 1, only if we want. We don't need it. Yeah, so 134. Okay, so all of these are more or less the same thing here. This is going to be the exact same problem. Okay, so any point estimate is always with this is proportion, not mean. But there's really only two, mean and proportion, for the most part. I'm talking about like 95, 99% of the time. If I'm missing one or two things, it's kind of in the rarity. But the only two you really have as far as point estimate is mean and proportion. So with population mean, the point estimate is literally just another name for the sample mean. With proportion, the point estimate is really just another name for the sample proportion. When they say point estimate of population proportion P, they're asking for the P hat equals X over N. we can read the thing, but we see that that's 548 is whatever it is they're looking for divided by total n of that. Yeah, so that's p hat there. Point 550. So we just talked about margin of error E, which is good. We have to do the whole confidence interval. There's the 95. So now the confidence interval is hard. We have to do the margin of error. Confidence interval is not easy. I'm trying to say the margin of error is not easy. There's a lot just for that. So let's kind of do this in some sort of an order here. So the margin of error for proportion is specifically this. It's z. We don't have to say alpha over 2. It's always alpha over 2. But it's z subscript alpha over 2. It's p hat, q hat, which is 1 minus p hat over n, the square root of that, yeah? So usually we start with the z, yeah, and then we have to do the whole thing. There's just a lot of room to make a mistake. So they kind of led us up to this. The z is all this stuff. We have the 95%, yeah. So alpha over 2 equals 1 minus 0.95 divided by 2. It's always, most people have it pretty well memorized with 95, 0.025. And then we have to inverse norm. Yeah, 0.025. This is so common that some people kind of, we get kind of some snickers if we do this because some of us have done the calculation 100 times, but 95% confidence intervals are one of the most common, and with a z-score, 95 is always going to be a z alpha over 2 is 1.96, almost exactly. So then we do the margin of error formula, and then we're done. So it's 1.96 on the outside of the square root. On the inside is p hat 0.550, in parentheses 1 minus 0.550 divided by n, which is 996. Only that part is in the thing there. Okay, good. So if we do that, I get, they want 3 decimal places there. I get 0.031. Okay, good. So they may or may not have us do the full confidence interval. Good. So in the end, what is all that? What do we have? We basically have this. This is the full process for a confidence interval. And we have kind of two things. So a confidence interval can be done for the most part by hand, which is what we're doing now, or we can just go into test and type in the data. The test has a list of all the most common hypothesis tests and confidence intervals. Is like a one prop z int or something. But what is the thing? That thing right there is the p hat. Yeah, plus or minus margin of error e. That's the point. The full notation is we have p hat is less than greater than. Yeah, no, it is to estimate population proportion. So in the middle, we have to have population. What is the point of a confidence interval? We're trying to estimate that population proportion. So we're saying, according to some theory, the lower bound is p hat minus e. That's one number. The upper bound is p hat plus e. That's a number. And that's an interval. And we're saying, we're hopefully with 95% confidence, that's a whole nother ball of wax, that it's in there. So we do that. If we remember these values, we just found that 0.55 minus 0.031 less than p less than 0.55 plus 0.031. So I'm getting, we have to have 3. I'm getting there. 0.519, 0.581. Okay. So then I like the math. I always want to make like a statement about this thing. Yeah, we're not allowed to say we should actually cover this. We're not allowed to say chance. It's not B. We're never ever allowed to say that there's a 95% chance. We're only allowed to say confidence.